Hello students, today we shall discuss about electrovalent or ionic bond. Ionic bond means there will be bond formation between opposite charged ions, that is positive charged ions, those are called cations, and the negative charged ions, those are called anions. Now which elements form cation and which elements form anion? The elements which contain 1, 2 or 3 electrons in their valence shell. You know the elements which contain 1, 2 or 3 electrons in their valence shell, they can lose these electrons easily to attain the nearest noble gas configuration, which is very stable electronic configuration. You know all about that. So those elements only can form cations, whereas the elements which contain 5, 6 or 7 electrons in their outermost or valence shell, those elements can accept electrons which contain 5 electrons, those can accept 3 electrons, which 6 electrons, which those can accept 2 electrons, and which contain 7 electrons, those can accept 1 electron. Thus by accepting electron, these elements can form anion. Thus two oppositely charged ions are formed, and once these two opposite charged ions are formed, that is cation or anion, there will be strong electrostatic force of attraction between them. Electrostatic force of attraction, or this is also called Coulombic force of attraction. And this force bind together these two opposite charged ions, and so that is bond is formed between these two opposite charged ions, and this bond is called ionic bond or electrovalent bond. Now why it is ionic bond? Because this bond is formed between two opposite charged ions. And why it is electrovalent bond? Because there is electrostatic force of attraction that is here playing the major role to bind these two opposite charged ions. So this is called electrovalent bond. Now here I am taking one example, that is the formation of sodium chloride, that is electrovalent bond. You know the atomic structure of sodium. For sodium the valence electrons are 2, 8, 1. And for the electronic configuration is 281, where 1 is the valence electron, and for chlorine the electronic configuration is 287, where 7 is the valence electron. So sodium can lose this 1 electron, and there will be formation of monopositive sodium losing this electron. As this is lost, so I am giving here negative sign, that is minus. This electron is lost here, so minus electron. Here the chlorine atom accepts this lost electron. This electron is accepted, as here exception is done, so here I am giving the positive sign. For chlorine, you know the electronic configuration is 287. 7 is the valence electron, so it will accept 1 electron to attain the nearest noble gas configuration, that is argon. The nearest noble gas of chlorine is argon, 288. By accepting 1 electron, the electronic configuration will be 288, and chloride ion is formed. Thus two opposite charged ions are formed, and there will be strong electrostatic or Coulombic force of attraction. This is the force of attraction between these two ions. Thus electrovalent bond is formed. So this electrovalent bond formation, that can be shown as redox reaction, that is oxidation reduction. Here you can see sodium here losing 1 electron to form the sodium plus ion. So as here electron is lost, so this is oxidation reaction. Sodium here gets oxidized to sodium plus, whereas chlorine here you know chlorine remains as chlorine gas, that is diatomic molecule. So chlorine Cl2, here one chlorine atom here accepting one electron, so two chlorine atoms here accepting two electrons, thus forming two chloride ion. As here electron is accepted, so this is reduction. So electron lost oxidation and electron accepted reduction. So chlorine gets reduced and sodium gets oxidized. Now if we add these two equations, here 2 electrons, so we have to multiply this equation with 2, then add these two equations. So 2 sodium, 2 electron will be cancelled out, 2 sodium plus 2 chloride, that is we are getting here 2 sodium chloride molecule. Here sodium gets oxidized and sodium is losing the electron, thus helping the chlorine atom to be oxidized. That is sodium here losing electron and help chlorine to get oxidized. So sodium to get reduced. So sodium here reducing agent, whereas chlorine here accepting electron, thus chlorine here indirectly helps sodium to lose the electron. So chlorine here helps in oxidation process, so chlorine oxidizing agent. So oxidizing agent itself gets reduced, whereas reducing agent itself gets oxidized. So this is sort of redox reaction actually. Now if we see the electrostructure of electrovalent compound, a large number of opposite charged ions come close to together, and there will be alternate arrangement in alternate fashion, that is one sodium, one chloride, one sodium, one chloride, thus a giant structure is formed. That is, this I am showing here one part of the ionic compound, and this structure can be extended in this side, in this direction, in this direction, that is, this is a giant structure and that can be spread up to infinity. And there will be alternate the opposite charged ions, there will be the ions in alternate position, that is one positive, one negative charged ions. So there will be force of attraction between two opposite charged ions, one sodium, one chloride, and there will be also force of repulsion between two similar charged ions, that is two sodium ions or two chloride ions. Two similar charged ions also here in close proximity. But here, so here two forces are acting, one is force of attraction, another is force of repulsion. But here the force of attraction is very strong than force of repulsion. So ionic compounds are very much stable, and due to formation of this type of giant structure, this is called ionic lattice. That you will know later in your higher classes. So due to formation of this type of giant structure, ionic compounds are very much hard and brittle, and they have very high melting and boiling point, because it is difficult to break this bond, electrostatic force of attraction between opposite charged ions. To break this bond, we have to give an enormous amount of energy, so they have very high melting or boiling point. Now this is very important, the electrovalent bond or the ionic bond, that can be shown by two type of structure. One is orbit structure and the another is electron dot structure. One is orbit structure and electron dot structure. Now I am showing here one by one. So this is the orbit structure of, say I am here taking the example magnesium chloride. This is the orbit structure of magnesium chloride. You have to draw the electronic configuration of magnesium. You know, for magnesium atomic number is 12, so the electronic configuration is 282. This is the nucleus of magnesium. Outermost, this is the K shell, 2 electrons, L shell, 8 electrons, and in the M shell, this is the valence shell, there are 2 electrons in the valence shell of magnesium. Now see the atomic structure of chlorine. You know, for chlorine the atomic number is 17. So the electronic configuration is 287. So there are in K shell 2 electrons. In L shell there are 8 electrons, and in M shell there are 7 electrons. So chlorine can accept 1 electron to attain the noble gas configuration, that is 8 electrons in outermost shell, and this is as there are 2 electrons in the outermost shell of magnesium, so it can lose these 2 electrons to attain valence electron to attain octet configuration. So here 1 electron from the outermost shell of magnesium, that is donated to chlorine, and here another electron is present in the valence shell of magnesium, so this electron can be donated to the another atom of chlorine. Thus 2 electrons are donated to the 2 chlorine valence shell. Thus there will be formation of magnesium bipositive because 2 electrons are here donated. Thus magnesium attain the noble gas configuration. This is the 2,8. This is the noble gas configuration of neon. And chlorine is here also accepting 1 electron for magnesium. I am here giving this electron is accepted, and this is the red dot. This is denoted by red dot, and this electron is accepted from magnesium. Thus in the outermost shell of chlorine there will be 8 electrons. So the structure will be 288, and chlorine becomes chloride mononegative as 1 electron is accepted. Similarly another chlorine, it also accepts 1 electron. Thus there will be 1 magnesium 2 plus and 2 chloride ions. There will be strong electrostatic force of attraction between these 2 ions. Thus there will be formation of magnesium chloride electrovalent compound MgCl2. And if we see the electron dot structure, for the electron dot structure, here we have to use the symbol of the particular element, then we have to show only the valence electrons. The inner electrons are not necessary here, so only the valence electrons, those are denoted here surrounding the symbol of the element. And these valence electrons can be denoted either by dot structure or by cross structure or hollow dot structure, like that. And these different structures are used, or different notations are used for electron to show the different electrons coming from different elements. For example, for magnesium, here the valence electrons are shown by dot structure, cross structure. So for magnesium there are 2 valence electrons, so 2 cross are used. And for chlorine atom, the dot notation is used for electrons. For chlorine we know there are 7 electrons in the valence shell, so 7 dots are used. And this is another chlorine atom. Now magnesium will donate 2 electrons to the 2 chlorine, so here 1 is donated, here another is donated, thus there will be formation of magnesium 2 plus. This is the stable electronic configuration, and there will be formation of chloride ion. This crossed electron, this electron is accepted from magnesium, so it is denoted differently and by red mark. So as there are 2 chloride ions formed, so 2 chloride ions are formed, and chloride ions mean there will be 8 electrons in the outermost shell. So 1 magnesium 2 plus and 2 chloride ions, and this is equivalent. There will be strong electrostatic force of attraction between these two. Thus there will be formation of electrovalent compound magnesium chloride. So these are the electron dot structure and the orbit structure of magnesium chloride. There are different other examples given in your book, like calcium oxide, sodium chloride. You have to practice them because these are very important for your examination purpose. Now here another term is electrovalency. In electrovalent compounds, electrovalency is the number of electrons which participate in to form the electrovalent compound. For example, sodium chloride. For sodium chloride, sodium plus and chloride minus formed. So here one electron is participating, so electrovalency of sodium chloride is 1. For example, calcium oxide, here calcium 2 plus and oxide 2 minus. Here 2 electrons are participating, as 2 electrons donated, 2 electrons accepted, so this is electrovalency for calcium oxide is 2. Okay, these are all about electrovalency. Thank you.